Okay, so again, this was your assignment last time. Let's check if you have submitted the correct answers for this. So let's start with the first one, letter D. The given is 2.4 times 10 raised to the power of -5 molar hydrogen ion. So this is the concentration of our hydrogen ion. Thus, we are going to compute for the hydroxide ion. And our formula for this is Kw is equal to H plus times the OH negative. Now, this Kw is constant. This is 1.0 times 10 raised to the power of -14. And then we have the H plus here, 2.4 times 10 raised to the power of -5. And then we are looking for the OH. Bakit ano? Okay. Wait. This one is division. 2.4 times 10 raised to the power of -5. Cancel this. So the OH here, what is your answer? Let us see. Ano answer niyo dyan?
2.4 times 10 raised to the power of -5. Ay, hindi daw.
4.17
4.17 times
raised to the power of -10.
Okay. Sige. 4.17. Well, let's check. 1.0 times 10 raised to the power of -14 divided by 2.4 times 10 raised to the power of -5. So round it off to 2 decimal places. Yes, correct. 4.17 times 10 raised to the power of -10. So the next question, is this acidic or basic? This is for the acid. This is for the base. H and OH, which is greater? Okay, very good. The higher there, the higher value there is this one. Therefore, the solution is most likely acidic. Okay, very good. So, dili na ta malibugan. This is not really a very hard computation, but you really have to make sure na you can properly identify which is higher among the OH and the H plus. So this time, the OH naman is given. So the same formula, so we will have the same constant. But this time we are going to compute for the H plus, and then the given is the OH, 5 times 10 raised to the power of 2. So divide both sides with this one. Cancel this. The H plus here, the concentration will be 1.0 times 10 raised to the power of -14 divided by 5 times 10 raised to the power of 2. So the answer, yes, is 2 times 10 raised to the power of -17. And just by looking at it, this is positive here and this is negative. So definitely this one is larger in value. So this solution is probably basic. Okay? So basic ito sa letter E. And lastly, we have for the F, the same again, 1.0 times 10 raised to the power of -14, and then the H plus is given. So this is 1.5 only. And then this is OH. Let's look for the OH. So the concentration of the hydroxide ion here, 1.0 times 10 raised to the power of -14 divided by 1.5 is 6.67 times 10 raised to the power of -15. And just by looking at this one is a whole number. This one is with a negative exponent. So definitely this one is larger. So letter F is also acidic. I hope you got the correct answers from letter D to letter F. Any question with the computation of the hydrogen ion and the hydroxide ion? This is one way of knowing whether a substance is acidic or basic. And itong pH class na calculation is really important for you kasi as medical technologist, you will also be testing pH. pH ng blood, pH ng urine, and if there are changes with the pH of the body, of these body fluids, then it will actually correspond to certain conditions. Nga kailangan nato siya agian. How do we get, if we do manual computation, the pH? But actually, in the laboratory, we have a lot of equipment or like apparatus that we can use para ma-measure yung pH. The simplest one is not really measuring the specific pH, but ano lang, tingnan lang kung acidic or basic yung ating litmus paper. Are you familiar with the litmus paper? The red one or the pink one and the blue one. These are just little papers that when you dip it in a solution, mag-change siya ng color. So if the blue one turns into pink or red, that means the solution is acidic. And vice versa, if you have a pink or a red litmus paper turning into blue, that means the solution is basic. So that's the most basic one to determine whether a substance is acidic or basic. But we also have pH meter in the laboratory or pH strips. So it's still paper class, strip pa rin siya kung titingnan. And meron yan siyang apat na parang box with color. And then you will be dipping this also in a solution. And then itong apat na boxes there will change in color. And then you are going to compare it with the standard. Meron yan siya sa box niya. Meron siyang like ganito sa box. And then corresponding to certain pH. So this time, the pH meter will tell us ano yung pH ng ating substance. You just have to look kung saang box siya magkapareho after dipping it in a solution. So again, iba-ibang color yan siya. Basta lang, i-compare mo siya sa lahat kung saan siya magkapareho. For example, all the colors in the 4 boxes there is parehas sa 3. It means the pH of the solution is also 3. That's the use of the pH meter. And remember our Sorensen pH scale. When you get a pH of 7, that means the solution is neutral. And then, if it is less than 7, the solution is acidic. If it is more than 7, up to 14, the solution is basic. So yan yung tatandaan ninyo when you're going to use the pH meter. So in this case, since excuse me, since the pH is 3, then that is lower than 7, the solution here is most likely acidic class. Yan yung gamit again ng pH meter natin. But the more sophisticated one is using the pH electrode. We really have a machine, an electronic machine, a little one only. Meron yan siyang screen there, digital display. And this one is connected to an electrode. And the electrode actually just looks like this. Connected ito siya dito. Okay, and then you're going to dip this one in the solution and then automatic it will give you here in the display the specific pH. Kasi ito, like 1, 2, 3 hanggang 14 lang, ito kaya niya even the decimal. So for example, 7.9. Yan yung the more sophisticated pH tester that we have. So I don't know with the laboratories here in Jensen, since pag like urinalysis or ang tawag dyan, CBC ako, meron namang decimal. So most likely they are using the electrodes kasi the pH meter will not give us the specific talaga, the exact one. Okay? Now, let's talk about pH and the POH according to the strength sense system. Kapag sinabing pH class, ano ba meaning ng pH? pH means power of hydrogen. Okay? Again, that's the meaning of the pH, power of hydrogen. Now, how do we compute for this? This is actually pH is equal to the negative logarithm of the hydrogen ion concentration. Since this is called the power of hydrogen, then again, if you want to compute for the pH, you need the concentration of the hydrogen ion. The hydrogen ion is being dissociated from an acid if it is placed in an aqueous solution. Do not forget, ang meaning ng pH ay power of hydrogen. Again, we compute the pH using this formula. Kino-compute natin siya. Manual computation if we know the hydrogen ion concentration. But then again, in the laboratory, that's another thing. But nevertheless, sa lecture, ito yung theory natin. Yung ating formula for the pH. Now, what are the sample problems involving computation of pH? We have here, what is the pH of a solution that has a hydronium ion concentration of 2 × 10⁻⁹ -9 formal? Now, remember that H plus can be substituted with the hydronium ion concentration. Though our formula is pH is equal to the negative log of H, pwede pa rin naman siyang pH is the negative log of the hydronium ion concentration. So this is the hydrogen ion, this is the hydronium ion. Now again, we are going to compute for the pH. Now, this one is the concentration of the hydronium ion, 2 × 10⁻⁹ formal. This is called formal or formality. Sa lecture, we discussed about molarity, molality, and normality, but we did not discuss formality. Nevertheless, this was a unit of concentration also, but this one is obsolete, meaning we don't really use this nowadays. It's almost similar to normality though. But if you get to see F sa mga chemicals natin, it's also a unit of concentration. So let's try. Let's compute for the pH. This is negative log of the hydronium ion concentration. So we will just substitute 2 × 10⁻⁹ -9. So in your calculators, just i-encode nyo lang. Negative, tapos log. Napin nyo yung log sa calculator ninyo. Do not forget the negative sign. 2 × 10⁻⁹ -9. And then round off your answers to 2 decimal places. Okay, you try. Okay. Yes, correct. That is 8.70. So if you have class A solution with this concentration for the hydronium ion, the pH will be 8.70. Now question, is this acidic, basic, or neutral? Ano ito? Acidic, basic, or neutral? Very good. This one is basic. So I told you a while ago that if the pH is more than 7, the solution will be basic. Or Or if you're going to look for like marketed products, ito yung tinatawag natin na alkaline. So like when you have their alkaline water, you will expect, if you are going to check the pH of the alkaline water, that will be more than 7. Okay? Ang ating tap water class, tap water that's coming from the faucet, and most of the bottled water natin, distilled water, are actually acidic. So if you test the pH of that, that will be lower than 7. So yung mga alkaline water na minamarket nowadays, it is actually true from the name itself that basic sila. The pH will be more than 7. Okay? Merong umiinom kasi niyang mga alkaline water. Okay, now how about this? This one is actually a reverse problem because the pH is given here and we are going to look for the hydronium ion concentration. So again, consider a solution with a pH value of 6.8. What is the hydronium ion concentration? Sige daw. Tingnan natin kung masundan ito. Nag-syntax error. How about the others? Sa i-transpose ang lang. Ako ba negative 8, negative 0.83, ang uban 0.83. Sige, let's check. Right? Okay. Diba this one is our formula, negative log of the hydronium ion concentration. And this one is baliktad. The pH is given. This is 6.8. This is 6.8. And this is negative log of H3O+. We are looking for the H3O+. So we are going to get rid of this negative log. How are we going to do this? Anong ginawa niyo?
Transpose mo.
Getranspose. Okay. The negative log cannot be transposed. Remember, when is the time that we are going to do transposition? If the operation is plus or minus, right? Sa mathematics, we do the transposition if it is addition or subtraction. But this is not addition or subtraction. This is actually multiplication. So, ang gagawin ninyo is to first, this one is going to be, bracket na lang. Ay, tama. Ang gagawin actually dyan is, you have to do anti-log. This is how you get the, the log. Negative. Do not forget the negative sign. Okay. Anti-log para makancel yung log. Okay? So, ang maiiwan dyan is H3O plus na lang. Now, dito sa kabila, you have the negative anti-log of 6.8. Or you can actually, para hindi siya mag-syntax error sa calculator nyo, lipat nyo dito sa number yung negative. Negative 6.8 siya. Kasi merong negative dito sa kabila eh. So again, mag-a-anti-log tayo. Na paano niyo siya gagawin sa calculator? Please take note. The anti-log is done through, pindot nyo yung shift log. Pindutin nyo again yung shift log sa calculator ninyo and then enter the negative 6.8. Again, shift log and then negative 6.8. What's the answer there? Decimal places. Okay, this time, it's already correct. 1.58 times 10 raised to the power of negative 7. This is the concentration of the hydronium ion concentration. I mean, hydronium ion na pala. Na-double na ang concentration. So the next time, class, you encounter mathematical problems involving logarithms, if you're going to get rid of that, since may hinahanap kang certain value or data, so just like this negative log of hydronium ion, you cannot transpose the log. Instead, you do the anti-log para makancel mo siya. So doing the anti-log in the calculator is just pressing shift tapos log and then enter the numerical data. Okay? So another question is this acidic, basic, or neutral? O certain na substance na ito. Okay.
Acidic.
Okay, very good. This one is acidic. Actually, this is, to be more specific, this is just slightly acidic. Bakit siya slightly acidic? Kasi it's near the 7 natin na tinatawag nating neutral. But nevertheless, it is still acidic. I-specify natin na it's slightly, very slightly acidic. It's almost neutral na kasi. Okay? Now, we also have the POH system. So the POH system is used for the alkaline or the basic substances. Now this time, this is naman the power of the hydroxide. So if you're going to look at its formula, it's actually the negative logarithm of the hydroxide ion concentration. So the formula is almost similar to that of the pH. So POH now is again equal to the negative logarithm of the OH negative. So let us have an example What is the pOH of a solution that has a hydroxide ion concentration of 3 times 10 raised to the power of -7 formal? Paspasaw eh. Paspa. Sige, sige. How about the others? Let's see the same, almost the same formula, ha? Negative logarithm lang of the OH. So we are looking here for the pOH. Sorry, ano siya? Ano siya? 6.52. Okay. The same way of computation, ha? But this time, this is for the pOH. So, negative log of the OH. Now, this is negative log of 3 times 10 raised to the power of -7. So, negative log of 3 times 10 raised to the power of -7 is, yes, 6.52. So this is plus the pOH of the solution. Okay? But if we're going to look for the pOH, we cannot easily identify whether the substance is basic, acidic, or neutral. Kasi our Sorensen system uses the pH only. Yung 1 to 14, that is for the pH only. So if ever you really want to know whether the substance here, which has a given na pOH, is acidic, basic, or neutral, you have to first compute for the pH. And I will teach you later how are you going to do that. Wait lang. Check ko lang if I have. Yes, I have sample problems of computation of pH if the pOH is given. So again, later magkakaroon tayo ng examples for that. Now, another one that we are computing for the pH or the acidity or basicity of the substance is the pKa. So this time naman, it's the power of the acid dissociation constant or the Ka. And yung formula nito, similar pa rin. Ano lang natin siya, palitan lang natin. So pKa class is the negative logarithm of the acid dissociation or equilibrium constant, which is called the Ka. Okay, this is the formula for the pKa. Again, negative logarithm of the Ka, acid dissociation constant. So sample problem, the Ka here, the acid dissociation constant is 1.75 times 10 raised to the power of -5. Find the pKa. Okay. Sige, how about the others? Yung Ka class ha is called acid dissociation constant. It's like product over reactant. Ito yung magiging constant for the substance kung gaano siya kabilis and gaano ka efficient yung kanyang pag-dissociate or pag-ionize when it is placed in aqueous solution. So the same pa rin ha ang formula. pKa is equal to the negative log of Ka. This time it's 1.75 times 10 raised to the power of -5. So enter sa calculator nyo negative log, tapos 1.75 times 10 raised to the power of -5. The correct answer here is 4.76. So ano yung pag-interpret ng pKa? The lower the pKa, the stronger the acid. Okay? This is how you interpret it. The The more na mababa yung value ng ating pKa class, it means the stronger the acid. So yung mga strong acids natin, like concentrated hydrochloric acid, you had your experience with the hydrochloric acid in the laboratory. You saw there that it has a strong smell. It actually releases fume. It's a strong acid, so definitely if you are going to compute for the pKa of that, you will get a low value of the pKa. Again, the lower the pKa, the stronger the acid will be. That's how you interpret the pKa results. Okay? Now, how about kapag kabaliktad? What is the acid dissociation constant or the Ka of an acid if the pKa is 3.3? Ano yung 5.01? Is that the answer for this problem? Okay. Paspas kayo sila. Lobat. Nahilig mong answer. Sige daw. Again, pKa is equal to the negative log of Ka. So we are looking here for the Ka. The pKa is given, that's 3.3. This is negative log of Ka. No, siya. This is Ka. And then again, anong ginagawa dito? To get rid of this, we do anti-log. We cannot do transposition here. So yung anti-log tayo dito, let's just place the negative sa 3.3. Okay, so in this side, you will have the Ka. And how are you going to do the anti-log? Shift log, tapos negative 3.3. The correct answer is 5.01. Do not forget the times 10 raised to the power of raised to the power of negative 4. So this is the acid dissociation constant if the pKa is 3.3. Okay, very good. That's 5.01 times 10 raised to the power of negative 4. Yung iba, 5.01 lang yung answer. Nawala si times 10 raised to the power of negative 4. So kindly check your answers saan kayo banda nagkamali. Okay? Questions about pH, POH, and pKa. Yun dyan yung hindi naintindihan. Kaya itong uliton. Hindi ka sinugdan. Wala. Sure na. So let's move on. Let's move on. Remember class, when we computed for the water ion constant, we have this formula. Diba Kw is 1.0 times 10 raised to the power of negative 14. 1.0 times 10 raised to the power of negative 14. And if you have a neutral solution, this one is equivalent to 1.0 times 10 raised to the power of negative 7. And this one is also 1.0 times 10 raised to the power of negative 7. Diba? Ito yung unang computation natin. Ito yung assignment ninyo. Okay, assignment ninyo ito. Anong tawag dito? Water ion constant, the Kw. Now, remember, pag kunin natin yung negative logarithm ng OH, you will get the POH. Nagkabaliktad lang yan silang dalawa. And then if you are going to get the negative logarithm of the H plus, you will get the pH. So, kapag inad natin ang pH and POH, hindi na KW ang tawag natin doon. pKW na. Okay? Power of the water ion constant. Now, since the water ion constant is called constant, meaning yan, hindi nagbabago ang kanyang value. So, if you're going to try, pKW is equal to the negative log of 1.0 times 10 raised to the power of negative 14. Wait lang ha, isulat ko. Negative log of the KW. This is negative log of the 1.0 times 10 raised to the power of negative 14. Anong sagot dito? The pKW is 14. Okay? So, kaya yung ating formula now becomes pH plus POH is equal to 14. In-explain ko lang saan galing yung 14 dito. Galing yan siya here sa KW, which is constant, diba? Hindi nagbabago. 1.0 times 10 raised to the power of negative 14. And since, remember, when you are going to compute for the pH, you use negative log of H plus, and then this one is the negative log of the OH. So this one naman, the pKW will be negative log of the KW. So pag i-compute natin, negative log of the KW, the pKW is 14. Okay, so dyan siya galing, class. And again, this one is constant. Hindi nagbabago. Hindi nagbabago ang kanyang value. So we have now a new formula, pero hindi naman siya mahirap. Ito yung gagamitan natin. pH plus POH will always be equal to 14. Hindi nagbabago si 14 ha. Thus, for the solution na neutral, since 14 yung ating total here, meaning the pH will always be 7 and the POH will also be 7. This is for the neutral solution. Pero if hindi neutral, class, syempre magbabago yung pH and also the POH. But as long as if we are going to add the two, we will always get the 14. Okay, 14 talaga pag i-add natin yung dalawa. Questions before tayo mag-move on? Wala na. Sige, mag-move on tayo. Igagamitin natin yung ating new formula for this sample problem. So number 1, what is the pH of the solution given that the hydroxide ion concentration is 1.6 times 10 raised to the power of negative 5. Okay? Ano daw yung ating given? The given in this problem is the OH negative, and that is 1.6 times 10 raised to the power of negative 5. Okay, and then what we are looking here is the pH. Okay, pH yung hinahanap. Now, take note that when you say pH, this is negative log of the H plus. Hindi mo siya makikita sa problem. Tama? Hindi makikita si H plus. Anong nasa problem? The OH. Now, ano yung formula natin na merong OH? Ito yung POH, di ba? Negative log of the OH, negative siya. So, therefore, you have to compute first for the POH. Negative log of the hydroxide ion concentration is 1.6 times 10 raised to the power of negative 5. So yan yung gagawin nyo ha. Pag OH ang given, tapos pH ang hinahanap, compute first for the POH. So this is negative log of 1.6 times 10 raised to the power of negative 5. The POH here is 4.795. I will not just round off ha, kasi I always do this when I am computing. I don't round off during the process. I round off only during for the final answer na siya. 795880017. But we are not yet done since the pH is asked here. So we are going to use that previous formula. The pH plus POH is equal to 14. Okay? So this is pH. We are looking for this. The POH is 4.795880017. And this is equal to 14. Now, ito yung time class na magta-transpose tayo. Okay, tayo magta-transpose here. Kasi our mathematical operation is addition. Okay? Addition kasi ito. So, magta-transpose tayo. And if nilipat natin itong 4.79 sa kabila, this will become negative. You know this. 4.795880017. Therefore, the pH is 14 minus 4.795880017 is 2 decimal points, 9.20. So the correct answer here is 9.20. Okay, very good. 9.20. Okay, 9.20 is Latin number. Okay, sige. Okay, nasundan yon. Any question about this? Wala. So is the solution basic, acidic, or neutral? Okay, very good. The solution is basic. If you're going to decide whether the solution is basic, acidic, or neutral, always look at the pH ha. pH tayo. Titingnan natin yung pH. We cannot judge using the POH only. So we need the pH here. And the pH is 9.20. That's above 7. So definitely this one is basic. Okay? Okay. So any question? May pangutan na mo, paano ni siya? Like, wala na sabtan din he. Basta always remember class, if OH is given, then pH is being asked. Compute first for the POH, and using the formula pH plus POH is equal to 14, you can compute for the pH. If it is the other way around, like yung H plus ang given class, example, H plus ang given, and then the POH is asked, ganun pa rin. Compute first for the pH, and using the formula pH plus POH is equal to 14, you can compute for the POH. Do not forget the 14, that is our constant. Okay? So, walay questions about that. Now, what is again the importance of knowing the pH of any substance? First, since we are all medical, like I am a medical professional and you are going to be a medical professional also someday, this one has an application sa medical world. So just like when you say human blood, our pH, ang normal pH ng human blood is between 7.35 to 7.45. If the pH of the blood becomes lower, the condition is called acidosis. And then if it is higher, we call that alkalosis. And it will cause serious problem with the person having either acidosis or alkalosis, or worse, pwedeng death can occur. Why? Because ang mga organs in the body cannot function well if the pH is beyond 7.35 to 7.45. So we need to keep that pH sa blood. Okay? Now, meron tayo, for example, if the person has high levels of potassium in the body, the person may experience acidosis class. Okay? The person may, kung marami na talagang potassium ha, so merong involve yung other na mga substance in the body here if mag-iiba yung pH ng blood natin. So again, example, if you have lots of potassium, the person may experience acidosis. So bababa yung pH ng blood, and then again, may corresponding effect yan sa body, and if hindi maagapan, death can occur. So aside from that, the urine also, the person class na mahilig kumain ng karne will most likely have an acidic urine. Okay? You can check that. And if you're going to test for the pH of the urine someday in the laboratory, you will really see that, again, the person who loves to eat meat, most probably acidic ang urine. Yung mga vegetarian naman natin, most likely yung pH ng urine nila is basic. So yun yung kaibahan, okay, para sa mga vegetarian. Now, for agriculture, yung pH naman ng soil natin will be an indication of what crop will be readily grown in that kind of soil. So since yung Philippines is like agricultural din na country, no, we also have to make sure na tama din yung pa-plant natin in a certain soil na pH. So if the soil is acidic, again, if the soil is acidic, yung plant na most likely mabubuhay, ito yung examples, the rice, coffee, banana, and pineapple. But if the soil is basic, you will have the grapes and the pechay. And for nearly neutral, we have corn, watermelon, peanut, cabbage, garlic, and onion. So question, sa South Cotabato in general, what do you think is the pH of the soil? Sa Brian? Sa South Cotabato, most of us galing tayong South Cotabato except for those from Sarangani. Okay. So sa South Cotabato, most likely in general, our soil is acidic. You can always check that with the crops na produced by the by the region, by the province. I mean, 'di ba? Mostly ng tanim dito class sa South Cot, rice, meron din coffee, 'di ba? And then marami dito ang pineapple and even the banana. So as you can see, ano yan siya, acidic. Acidic yung ating soil dito. Ang sarap volcano. Naghanap volcano din here. We have the Mount Matutong and ano yung nasa ano? Ano nga yan? Sa may Lake Hulon.
Mount Parker.
Mount Parker. Yeah, Mount Parker pala. Mount Parker, but they are inactive. Lisod po kung mag-active sila, no? Lisod magay kay effect sa Taal Volcano nga gamay kayo siya. Siya ang pinakagamay pero active kayo siya. Pero ang sa ato man good, these two are inactive. Now, aside from that, yung mga products natin sa market, commercial products, the shampoos that we use have pH between 4 to 6. But what is the importance here? You can see yung mga baby na shampoos. Para sa baby na shampoos, may nakalagay no tear formula. Okay, no tear yan siya kasi in-adjust ang pH. The pH of that is 7.4 and that is similar to the pH of the human fluid, the human blood, and the human body, the human eyes. Okay? So, di ba, yung human blood is between 7.35 to 7.45. That is not just true for the blood, it is also true for the eyes. So, itong mga shampoo ng babies natin, in-adjust yung formula na 7.4. Even if mapunta sa mata nila, hindi siya masakit. Okay? Yung sa yung mga shampoo na ginagamit natin sa mga adults, 4 to 6 siya. So, hindi siya magkapareho ng pH ng mata natin. So, pag mapupunta siya sa mata, that will really be painful. Okay? So, yan yung explanation. Hindi magkapareho ng pH. And then, yung production ng ibang mga products like beer, wine, vinegar, and cheese follow strict protocol in terms of the pH. So, para ma-preserve sila for a longer shelf life. Para hindi sila agad masira. There is a strict control of the pH there. So, yan yung mga examples ng mga application of the pH and why do we need to really know it, and why do we compute for it? Kasi may mga applications yan sila. Now we have here the indicators. So when you say indicators, we use this class to determine either calorimetrically or electrometrically the pH of the solution. So sa titration process, I think we defined terms for titration and isa na doon si acid-base indicator. Pag sinabing acid-base indicator, it's a compound, it's a chemical substance that when you are going to place it in a certain pH, mag-change siya ng color. Diba? Sa titration, pag nag-change na ng color, it means the endpoint na siya. Ang dahilan nun because of the acid-base indicator. That will actually be our ang tawag dyan, next na face-to-face laboratory activity. Sa na yon siya sa finals. You will all be asked to do titration. So you are going to use, syempre, acid-base indicator so that you will see the change in colors. So these are the examples of the indicators. Again, these are chemical substances that change color depende sa environment. So just like when you say phenolphthalein, pag nilagay mo si phenolphthalein in acidic medium, example, nilagay mo siya sa suka or sa vinegar. So remember, vinegar is acidic. Phenolphthalein will be colorless. But if you place phenolphthalein in a basic environment, just like when you place it in sodium hydroxide, hinalo mo siya sa sodium hydroxide, you will get a red color, or it may be a pink or red color. So yan yung gamit ng mga indicators class. Somehow they can also identify the acidity or basicity of a solution. Okay, depende sa color na ipoproduce nila. Now, if you're going to ask me, ma'am, do we need to memorize this? Yes, you need to memorize the colors of the indicators depende sa environment. Now, how do you memorize this? Actually, ganito. Let me check. I only have this one pala. Actually, ganito. Ano yan siya? Color na nasa pangalan nila, yan yung magiging isang color nila class, depende sa environment. And then always yan siya yung kanilang partner ay yellow. So like malachite green, let's start from the bottom. Malachite green, nasa pangalan niya yung green. So acidic environment, green ang color niya. Automatic yung partner niyan ay yellow. Now, itong bromocresol blue. Blue yung magiging isang color niya, pero this time it will be in the basic environment. And then again, yellow yung kanyang partner. I-check ko yung mga exceptions because we have exceptions here. The phenolphthalein and the thymolphthalein. Kasi si thymol blue, ganun pa rin. Since merong blue dyan, one of its color will be blue and then always the partner will be yellow. So ito din, si cresol red, si methyl red. Red din yung kanilang isang color and then yellow yung kanilang partner. You just have to identify whether the red one will be acidic or basic. Ito yung ating yung chinek ko, exceptions yan kasi wala namang color sa pangalan nila. Phenolphthalein and thymolphthalein, but yung partner nito sa ibang color is the colorless. So sa phenolphthalein, it's red for the basic one, blue for thymolphthalein, and then ang partner nila sa acidic environment will be colorless. Okay? Pero ang pinaka-ginagamit natin sa laboratory is this one, the phenolphthalein. So ito yung magiging comparison. If phenolphthalein is placed in an acidic medium, you will get a colorless solution. But if you add, for example, phenolphthalein in sodium hydroxide, you will get this color of the solution. Kung nag-titrate pa taani, kung we do titration, you will really see this sa endpoint. Meaning, if the color becomes like this during the endpoint, it means you have to stop the titration process. Kaya siya tinawag na endpoint kasi stop na. Hindi ka na mag-a-add ng more substance pa. Okay? Questions? Anyone? Or clarifications? Wala? Do we still have time? It's 8:41. Sige. Wala question. So let us continue. We have here the buffer solutions. So when you say buffer solutions, they are solutions definitely that will resist changes in pH of the solution. If ever there is addition of an acid or a base to your original solution. So ito yung actually buffer solutions are components of our products in the market just to really keep the pH at a certain level. Nagdadagdag tayo ng buffer solution. So for example, yung no tears formula ng mga shampoo ng infants natin may have buffer solutions. Bakit? Idadagdag siya doon to keep the pH at 7.4. Okay? Kasi mga products natin might have changes in pH, especially if the environment is not favorable. Example, mainitan, mabilad sa init, no? Mag-change yung pH nila. So, since meron ng buffer solutions in that certain formulation, magre-resist. Ito yung magiging dahilan na hindi mag-change ng pH yung solution mo. So kung makakakita kayo ng formulations tapos nakalagay doon, buffer solutions, ano yung kanyang role dyan? That is to resist changes in pH of the solution. Changes in pH of our solution means the product can be destroyed and can become useless. Okay? Pag nag-change yan sa ng pH. Now, yung mga buffer solutions natin are just mixtures. Mixture ito, whether of a weak acid and yung salt niya, pero pwede din namang weak base and yung kanyang salt. So, ito yung examples class ng buffer solution. Pwede siyang mixture of acetic acid, which is a weak base, and yung kanyang salt, the salt is called sodium acetate. Now, pwede din tayong magkaroon ng weak base na buffer solution. So, we have there ammonia water. That is the weak base class. And then, yung salt is called ammonium chloride. Okay, so this is one buffer here. Again, this is one buffer here. This is another buffer. So, we can add this in our certain product just to keep the pH at a certain level or a certain range. Magre-resist siya ng changes in pH. If meron kang i-add na either acid or base deliberately, or if the environmental condition is not favorable. So magre-resist pa rin siya ng changes in pH. Now, we have the so-called Henderson-Hasselbalch equation, which is also known as the buffer equation. Okay, this is the buffer equation. It's called Henderson-Hasselbalch equation. Now we have two equations here for the Henderson-Hasselbalch. This is how you're going to compute the pH of the buffer solution. Since it's a mixture, right? It's a mixture. So pH is equal to pKa plus log or logarithm of the concentration of the salt divided by concentration of the acid. So you're going to use this formula if you use a weak acid in the preparation of the buffer. Now, ito namang sa baba, pH is equal to pKa plus log of the concentration of base divided by the concentration of salt is used if your buffer is made up of a weak base. So, dalawang formula yan na kailangan yung tandaan. Pag weak acid, ang acid ang nasa baba, salt ang nasa taas. Baliktad yan siya kapag ka-base. Base ang nasa taas, salt ang nasa baba. Again, when do we use this equation? If we are going to compute the pH of the buffer solution. Kung kapag gagawa tayo ng buffer solution, example, gusto natin paghaluin si acetic acid and si sodium acetate, buffer solution na ang tawag doon. Kasi weak acid si acetic acid and then si sodium acetate is a salt. So, ko-compute natin yung pH niya. Okay, so example. What is the pH of the solution containing 1.3 molar acetic acid and 0.9 molar sodium acetate? The pKa is 6.8. You have to identify first class the given. Given ka muna. So we have here the pKa is 6.8. And then you have their acetic acid. Remember, from the name itself, acetic acid, this is an acid, ang concentration niya 1.3 molar. And then yung sodium acetate will automatically become the salt, and ang concentration is 0.9. Okay? Bilis na. So we have again here, our formula is pH is equal to pKa plus, since this is an acid, so we will be using this formula. Okay, si acid ang sa baba ha. So pKa is 6.8. This is plus logarithm of salt ang nasa taas, so this is the concentration, 0.9. Divided by the acid, it's 1.3. So, actually, pag nilagyan mo siya ng bracket, pwede nang hindi ka maglagay ng unit. So, this is 6.8 plus logarithm of 0.9 divided by 1.3. Medyo mahaba. Kopyahin ko lang siya. 0.69230. 76923. Tapos, 6.8 plus log of this. So, log of 0.69230, 76923 is negative 0.1597008429. So, i-add natin siya doon sa 6.8. The answer is 6.64. So this is now the pH of the prepared buffer solution. It's 6.64. Ito ang topic ito yung i-quiz natin bukas. I just don't know. Exam na next week, right? Tama ba? Anong araw
Yes, ma'am.
Anong araw yung exam? Monday talaga. Parang hindi kasi Monday yung exam, di ba? Let me check. Kasi kung ano, i-clarify ko muna ha, kung hindi Monday yung exam, sa Monday ako mag-quiz nito para you will have more time to absorb this. Pero kung ano, kung wala nang klase sa Monday kasi exam na siya, most likely mag-quiz ta ugma. So be prepared na lang. Okay? Be prepared. Because I'm not really sure. Okay? So any question about this? Nasundan yon? You have to properly identify from the name itself acid. So definitely this will be the acid. And automatic sodium acetate will be the salt. Okay? Next, sige, you try. This time, the pH is given. That's 8.1. And we are looking here for the pKa. But the solution is made up of 0.6 molar ammonium chloride and 1.13 molar ammonia water. Still have like 5 minutes. 6 to 8. 6 to 8. Sige, next week tayo mag-quiz na to, class. Next week. 6 to 8 man daw ang exam. So, meron pa tayong like Monday. That's April 4. Sure. Sige, let's wait for more answers from the others. May mo answer. $8.54. Sige. Let's try to solve for this. The pH, the same, no, not the same formula. Because take note, ammonia water is our base here. So we will be using the formula base over the salt. So, dito, given yung pH, so ilagay natin 8.1. We are looking for the pKa. Ay, this is plus log. And then yung base, take note, that is the ammonia water class. So this is 1.13 sa taas. Sa baba yung ammonium chloride, which is the salt, 0.6. Malalaman mo naman yan pag salt class, it is made up of positive and negatively charged ion. Okay? Si ammonia water, NH3 lang siya. Pero baliktad, diba? N is negatively charged, hydrogen supposedly is positively charged. So, hindi siya nag-follow sa totoong salt natin. So, this is 8.1. Sa baba na lang ha. 8.1 is equal to pKa plus log of 1.13 divided by 0.6 is 1.88 and then continuous na 3. So 8.1 equals pKa plus the logarithm of 1.833 is 0.2749 27193. 27191. And then we are looking for the pKa. So what are we going to do? This is addition. So magta-transpose tayo sa kabila. Ang maiiwan dito sa right side is the pKa. This will become now 8.1. Tapos, di ba, magiging negative yung transpose natin. So this is negative 0.2749271,931. Therefore, the pKa is 7.83. 7.83. So this is our pKa. Okay? Who got the correct answer? 7.83. Si ano? Si Darlene. Mag-base sa given if base or acid. Ayan sa from Senta. Okay. So again, mag-base sa given if anong formula yung gagamitin. Since ang given here is ammonia water, you are going to use this formula. So base kasi ito, 'di ba? Hindi mo naman siya pwedeng tawaging acid. Hindi naman siya acid. Most of our acids have acids in their name. So that's the simplest thing na gagawin para ma-identify mo siya as acidic or basic. So ito ang magiging salt. Pero pag acid, baliktad yung formula natin, class, 'di ba? Yung sa acid, sa baba ang acid na concentration, sa taas yung salt. So be familiar first with the formula. Hindi nyo pa siya na-absorb ngayon, pero next week na tayo mag-quiz para you will have more time to really absorb everything. Kasi I'm almost done pala. We will have more examples tomorrow na lang sa ating computation. So ganun na lang, hindi muna ako mag-quiz and then I will discuss this polyprotic acid tomorrow also since it's already 8:58. For the meantime, do you have questions or clarifications? Wala. Okay, so let's